Let's take a look at 1.1.1. We have x multiplied by x minus 3 being equals to 0. We're solving for x. It's either x is equals to 0 or x minus 3 is equals to 0. One between the two, right? So x equals to 0 or x is equals to 3. That is the answer to 1.1.1. We are sticking to the basics, really. Nothing complicated. Right. Let's take a look at 1.1.2. We have 2x squared plus 1 being equals to 4x. And we're supposed to solve for x correct to 2 decimal places. As soon as the question says correct to 2 decimal places, we are thinking that we might have to use the quadratic formula, the quadratic equation. So to write this in the standard format, we would have 2x squared minus 4x plus 1 being equals to 0. So this is A, this is B, and this is C. Right. So now we're going to say that x is equals to minus b. So minus b in this case is, well, 4. It's minus 4 is b in this case. And then plus or minus the square root of b squared, right? So minus 4 squared minus 4ac. A is 2, c is 1. And then we divide everything by 2a, of which a is 2, right? So we have x being equals to. So without wasting time, let me just go ahead and substitute this in my calculator. So we're gonna have plus 4 plus the square root of minus 4 squared minus 4ac. A is 2, c is 1, divided by 2a. Well, a is 2, so I'm getting x is equals to 1.71, or x is equals to, so let me change the positive to a minus. We have 0.29. 0.29. These are our two answers, 1.71 and 0.29. There's no other answer except from this. 1.70 something is wrong. 0.293, 0.2928. It is completely wrong. The question says correct to 2 decimal places. There's no ambiguity when it comes to rounding off. So these are the only 2 possible options. Right, 1.1.2. Let's take a look at 1.1.3. So 1.1.3, x squared minus 2x minus 3 is greater than 0. So here we are solving for x. I'll go ahead and find my critical values, right? In saying that CV, right, I can then equate these to 0 and find those critical values of x, and then worry about the answer after. So x squared minus 2x minus 3, we can easily factorize this, right? 2 factors of minus 3, when we add, we get minus 2, and when we multiply, we get minus 3. That is minus 3 and plus 1. This is equals to 0. Well, we can test this out. This is going to give us x squared minus 3x and then plus 2x minus 3. So x squared, actually, let me do that again. I know that this is how it looks like when it's factorized. So x and x will give us x squared, and then we have plus x, and then we have minus 3x, and then we have minus 3. So this is going to be x squared minus 2x minus 3. Okay, so I've done that in the correct way. So these are the critical values. X is equals to 3 or x is equals to minus 1. Like I've said on countless videos, there's 2 possible solutions when we get to this point. It's either x lies between the 2 critical values or it lies outside. Let me show you what I mean when I say that. If it lies between the 2 critical values, I'm saying that x is between minus 1 and 3. And when I say it lies outside, I'm saying that x is less than minus 1 or x is greater than 3. These are the possible solutions, A and B. These are our possible solutions. There's no other solution apart from these 2. So how do we therefore test which solution is correct? I'm glad you asked. Take a look at this. So we can substitute a number that exists in this solution, right? A number between minus 1 and 3 is 0. If we substitute that number in our equation and our condition, well, our inequality is satisfied, then A is our solution. But if that is not the case, then B becomes our solution automatically. So let me substitute 0. 0 squared minus 2 multiplied by 0 minus 3. So when you substitute 0, we get minus 3 is greater than 0. Is this true? We know it is not. So it means that this is not the solution. This is not the solution. We can get rid of this. This is not the solution. So the solution, x greater than 3 or x less than minus 1. This is the actual solution. We can obviously test that out. We can substitute 4, for instance. When you substitute 4, we get 4 squared minus 2 multiplied by 4 minus 3. That is 5, and 5 is clearly greater than 0. So that is the solution, 1.1.3. 1.1.4, we have 2 to the power 2x minus 2 to the power x plus 2 minus 32 is equals to 0. So as soon as I see equations like this, I know that I'm going to let something be equals to k, right? I'm going to let something be equals to k. So let me show you how this plays out. So 2 to the power 2x, we can write it as, well, 2 to the power x, everything to the power 2, right? 2 just multiplies 2, just multiplies x, and we end up with 2 to the power 2x. And then here we can write minus 2 to the power x multiplied by 2 to the power 2, because when we multiply numbers with the same base, we add the exponents. So that is totally fine. And this we can leave as minus 32, and this is equals to 0. So we can let 2x be equals to k, right? In doing that, we will therefore have k squared minus 2 squared is 4, right? So we have minus 4k minus 32 being equals to 0. And then we can just go ahead and factorize this. So let me give that a try. We have k, and then 2 factors of minus 32, of which when we add, we get minus 4. I think minus 8, let's say minus 8 and plus 4 would work. Let's just give this a try and see. So this would give us k squared plus 4k minus 8k, 8, 16, 32, minus 32. So k squared minus 4k minus 32. So I'm quite convinced that what I've done is correct, right? That is how you can always check. You can just multiply out and see if you go back to the same thing. So k is equals to 8, or k is equals to minus 4. But we know that k is 2 to the power x. So 2 to the power x is equals to 8, or 2 to the power x is equals to minus 4. Obviously, we know that this is impossible. So we cross it out and we forget about it. Now let's focus on 2 to the power x being equals to 8, right? So 2 to the power x, we write 8 with a base of 2. So that is 2 to the power 2 is 4, so 3 is 8. So x is equals to 3. That is 1.1.4. Quite simple. It's not too bad. It's not too bad. This is easy, right? 5 easy marks. Right. And then 1.1.5, we have the square root of minus 2x plus 4 minus x being equals to 2. This is another basic one, right? We know exactly what we're going to do. We're going to isolate the square root here. We're going to be left with minus 2x plus 4 being equals to, well, let's just say x plus 2, because x is going to be positive when it goes to that side. And then we square both sides. Right? Sticking to the basics. When we do that, we get, let's say, minus 2x plus 4. I wanted to say 4 minus 2x, but it's fine. We can just leave it like that. And then x plus 2 squared, that is x squared plus 4x plus 4, right? Yes. Okay. I'm happy with that. So we're going to have x squared plus 4x plus 2x when we take it to the other side, right? So we get x squared plus 6x, and then 4 minus 4, that gives us 0. So we have x squared plus 6x being equals to 0. So take x as a common factor, we get x plus 6. This is equals to 0. So x is equals to 0, or x is equals to minus 6. Right, most of the time when we square, we introduce solutions that are not necessarily true for the equation when it is not squared. Let me show you, let me demonstrate what I'm talking about. So x is equals to 2. Well, what is x? X is 2. It's easy to see. We're saying that x is equals to 2. But take a look at this. If we square both sides, which is mathematically correct, we get x squared is equals to 4. But what are the solutions of x squared is equals to 4? X is equals to 2, or x is equals to minus 2. So when you square, you introduce things that might not be necessarily true for the original equation. So we need to test and see which one between these two it is not necessarily true. It is possible sometimes that they are both correct. Sometimes you can find a case like that, but let's test it out. Okay, so when I substitute 0, right, I'm substituting here, and after I substituted here, well, it's supposed to give me 2. So minus 2 multiplied by 0 plus 4 minus 0. This gives me 2. So x is equals to 0. It is working, right? Now let me substitute minus 6. So the square root of minus 2 multiplied by minus 6 plus 4 minus 6, right? Because that 6 is negative. And then here I get 10. 10 is equals to 2. Obviously 10 is not equals to 2. So x is equals to minus 6 is not necessarily true for the equation that we started with. That is 1.1.5. Let's take a look at 1.2. So here we have 2x plus y being equals to 3. Well, it's easy to see that our life will be easy if we make y the subject of the formula. If we do that, y is equals to 3 minus 2x. You can call this equation 1. You don't really have to do that, but yeah, you can do that. And then now we have x squared plus xy being equals to 2. This is our second equation. And then in place of y, we substitute 3 minus 2x. We square that. Plus x 3 minus 2x is equals to 2. So let's solve 3 minus 2x squared. So this will give us, 4x squared minus 2x multiplied by 3, that is minus 6x. We multiply that by 2, minus 12x plus 9 plus 3x minus 2x squared. And this is all equals to 2. So 4x squared minus 2x squared, that is 2x squared, minus 12x plus 3x, that is minus 9x. And then 9 minus 2, right? That is plus 7. So if you forget these two here and you equate to 0, then yeah, it's not going to work out. And then this is equals to 0. Obviously, it is very difficult to factorize when we have a coefficient of 2, when the coefficient of x squared is 2. But if you find your way and you factorize, you should get 2x minus 7. And then here you have x minus 1. But it's always safe to use the quadratic formula. And then x is equals to 7 over 2, or x is equals to 1. Right. So now we need to find the corresponding values of y. So when x is 7 over 2, what is the value of y? So 3 minus 2 multiplied by 7 over 2. I'm getting minus 4. So one possible value of y is minus 4. What about the case where x is equals to 1? So 3 minus 2 multiplied by 1, I think that just gives us 1. 3 minus 2 multiplied by 1, that gives us 1. So y is equals to 1. Okay, and then let's take a look at 1.3. I did post a video on a question like this not too long ago. So let's take a look. Determine all the values of n for which the product will be an integer value. Let's do that on a separate video. Here we go. So let me know in the comments which video you want me to do next. Right now I'm doing 1.3 and I'm going to upload it right now. But tell me, after 1.3, which question should we do next?